number theory.
All right, welcome to another episode of King Solomon and David Picosi on algebra. And today we'll be starting with the introduction to the number theory. The introduction to the number theory. Now, with number theory, it's simply the study of or the theory about numbers. You want to understand the laws and theories behind numbers. So we'll be looking at what is known as what the natural numbers, what is called the integers, um, the rational numbers, the irrational numbers, and a real number. So when you say real numbers, what does it mean? Okay, so these are 5 basic things that will help us introduce the course algebra. That is the introduction to the number theory. But before I come here, I want to talk about what is known as the closure property. A closure property. So now, a closure property is very simple. If you operate, that's any of the operation sign, the addition sign, the subtraction sign, the division, the multiplication. When you operate on any of these signs with real numbers and the answer gives you a real number or it equals a real number, then we can say that property is closed. Or that operation is a closed property. So if you operate on any of these and you are still getting a real number, then we say that operation is a closed property. So for instance, when we take under addition, let's see whether addition is a closed property. So when I take two numbers, let's say A plus B, and A and B are real numbers. A plus B will obviously be equal to a number C, and C will also obviously be a real number. So for example, if I have 2 plus 3, I'll be getting what? 5. 2 plus 3, they are real numbers. The same way, the 5, 2 plus 3 are natural numbers. And the 5 is also giving me what? A natural number. So this is what? A closed property. So what can we say? We can say addition is a closed property. Why? Because when you operated on 2 real numbers, you still get what? A real number. Now if you check subtraction, is it a closed property or not? Now, many times it consumes, like, let's take for example 2 minus 5. When you do 2 minus 5, you are getting minus 3. Do you get it? So now that is to say A minus B, where B is greater than A, you'll be getting a minus answer. Now, these two are real numbers, but the answer it gives, or these two are integers, but the answer it gives is not a real number. These two are integers, but the answer it gives is not a real number. This 5 is a real number. 5 is a real number. So this, it is not a real number. So since it's not a real number, then we say subtraction, it is not a closed property. It is not a closed property. Now when you check on the division, let's look at the division. So with the division 2, okay. So with the division, let's say I have 17 on 2 divided by 2. These two numbers, the 17 and the 2, are natural numbers. The 17 and 2 are natural numbers. So when I come and I'm defining the natural number, you get it very well. The 17 and 2 are natural numbers. But when I operate on them with the division, I get 8.5. Now the 8.5 here is not a natural number. 8.5 here is not a natural number. Therefore, division is not a closed property. division is not a closed property. And the last one is multiplication. Multiplication. So with multiplication, if I have A multiplying B, I'll get C. Obviously, A multiplying B, I'll get C. So since A and B, if they are real numbers, then I'm getting C, which is also a real number. If I have, for instance, let's say 5 multiplying 6, I'll get 30. 5 and 6 are real numbers, 30 is also a real number. Therefore, multiplication is a closed property. So this is just a little introduction about closure property. So now, what can we conclude here? Our conclusion is that under these operations, it's only two that I have a closed property. That are closed properties. That's the addition and the multiplication. These are the only two that has the closure property. Let's go straight to what we mean by natural numbers, integers, rational numbers, irrational numbers, and the real numbers. Okay. So now, when you say a natural number is simple, a positive integer. So the natural number is simple, a positive integer. Okay. So now, it's that, and it's what we use most of the time in our counting. So you start 1, 2, 3, 4, and upwards. So this is what we call the natural numbers, positive integers. So anytime you have a natural number, it should be greater than 0. A natural number should be greater than 0. So all positive values, or positive integers are natural numbers. But one thing you should note is that under natural numbers, they are always closed under the operations of addition and multiplication. They are always closed under the operations of addition and multiplication. So anytime you have a natural number, let's say 2 plus 4. 2 plus 4, I'll get 6. If I have 4 plus 2, I'll get 6. 2 times 4, I'll get 8. 4 times 2, I'll get 8. So now, per the closure property we did, you realize that natural numbers are closed under the operations of both additions and multiplication. Now, what are integers? What are integers? Now, with integers, they are both positive, negative, and the number 0. So now, integers are the set of integers one contains the positive integers. That's the positive natural numbers or the natural numbers itself. The positive integers, you have the negative integers and the number 0 itself. So these are all what we call a set of integers. So now what we can say here is that we can have -3, -2, -1, you have 0, you have 1, you have 2, you have 3, onwards. These are all examples of integers. Now what can we say is that integers is what brings about equations such as x plus b is equal to, let's say, a, where you can find x is equal to a minus b. So in such cases like this, if b is greater than a, you are getting perhaps x equal to a minus b, and the x value will obviously be a minus answer. And this can be a negative integer, or the c value can be a negative integer. So if you have maybe 2 minus 5, you are getting a minus 3. So integers help us generate equations of this nature. Now, there are some. Okay, so with integers, there are some properties we have to look at under the integers. So one, let's look at the associative property. Associative property under the integers. So with the associative property, if we have something like a plus b, A plus B plus bracket open B plus C. Then we can have A plus B into brackets plus C. So this is an associative property. Okay. It also works for commutativity. And commutativity is very simple. If you have A plus B, it should be the same as what? B plus A. Same way, if you have AB, it should be the same as what? BA. That is the multiplication aspect of it. Thirdly, is distributive. So distributive in the sense that we are adding both the addition and the multiplication in its equation or in its term. So we can have A multiplying B plus C, and it's the same as A multiplying B plus A multiplying C. And this is the distributive property. There are other properties like the identity, and it goes like if you have any integer plus 0, then you get the same integer. Okay. We have other property like an integer plus multiplied by 1 should be the same number. So now this becomes the additive identity. This becomes the multiplicative identity. Okay. Now we also have another property known as what? The transitivity. So the transitivity property. And the property states that if an integer A is greater than an integer B, and an integer B is greater than an integer C, then obviously the integer A will be greater than the integer C. So now the transitivity states that if A is greater than B and B is greater than C, then it implies that A obviously is greater than C. The seventh property we're looking at is the trichotomy. The trichotomy property. And the trichotomy property says that if you have A greater than B, and you have A, you can have A greater than B, you can have an integer A which is also less than B, or you can have an integer A which is equal to B in certain circumstances. Okay, so we have our eighth property, and which is the cancellation law property. So the cancellation law property says that if you have an integer multiply another integer equal to, so maybe you have A multiplying C, and it's equal to B multiplying C, so the same integers here. Then, and C is not equal to 0, because if C is equal to 0, both will go to 0. And C is not equal to 0, then you can say A is equal to B. And this is what we call the cancellation law property. So what you can do simply is that if A dot C is equal to B dot C, you can simply cancel the C out, and you get A is equal to what? Is equal to B. Okay. Now let's move to rational numbers. Rational numbers. These are numbers that contain fractions. So rational numbers, these are numbers that they contain fractions. So these numbers can be written in the form as A equals B. And it is out of these numbers we can have equations like AX is equal to B. So to find the value of X, you get X is equal to B on A. And this is a rational number. So now, this works if B is not equal to 0, and here too, if A is not equal to 0, you get a rational number. But you should take note on something over here too. Rational numbers operate on division. Rational numbers operate on what? On division. Integers operate on subtraction. Integers operate on subtraction. So rational numbers, it operates on division or the inverse of multiplication. So the inverse of multiplication is the division. Integers operate on subtraction or the inverse of addition. Or the inverse of addition, and natural numbers only operate on the addition aspect. So now, this is what you can see as the natural numbers. So for here, A should not be equal to that. So now if you have B greater than or equal to 1 or B less than or equal to 1. So B shouldn't be equal to 0, but it can be any of these problems. And it's just to understand that if that is the case, integers are subsets. Integers are subsets of rational numbers. Integers are subsets of rational numbers. Okay. Now let's see, we look at the irrational numbers. Irrational numbers. So example of the irrational numbers are root of 2, comma, you can have 5. They are all irrational numbers. They are irrational numbers because they are not rational. And they cannot be expressed in the form A on B, which is called the quotient of A or B. So irrational numbers, example root 2, the pi, they cannot be expressed in this form A or B, which is called the quotient of A or B, where A or B are integers. They cannot be expressed in this form where A or B are what? Are integers. Okay. So getting this, the last thing we look at is the real numbers. And I want to use a diagram to explain the real numbers, which is very, very simple. The diagram to explain a real number. So now, to understand a real number, so if you consider a set, so a real number becomes a universal set. So we can consider two disjoint sets. And this one is called rational numbers. And this is called irrational numbers. You say irrational numbers can never be rational. Irrational numbers can never be rational. So now, as I said, integers are subsets of a rational number. And natural numbers are also subsets of what? Integers. So now, if you have this, it will easily make you understand what is a real number. So we say a real number is simple rational number plus an irrational number. So if you add a rational number plus an irrational number, you get a real number. So realize that in all the number theory, real numbers are the broadest of all. Real numbers are the broadest of all. And I believe this will give us a good introduction to our number theory. Let's move on to principles of mathematical induction in our next video. Thank you.